Once again, in this Try It exercise, we are asked to solve the system of equations using substitution. And once again, let me remind you, you can solve for y in either equation and then substitute it into the other equation. But typically, especially right now, you're going to have one equation that it's simpler to substitute. In this case, we're given x squared minus y equals 0 and y equals 2x minus 3. Since the second equation is already solved for y, we're going to go ahead and substitute that into the first equation in terms of x. So we have x squared minus y, which our second equation says that y equals 2x minus 3. Be sure to put that in parentheses so you don't lose the negative. That has to be distributed. And that's equal to 0. So simplifying, we have x squared minus 2x plus 3, because it's minus negative 3, equals 0. And now let's check the discriminant. B squared minus 4ac. Remember, if that's greater than 0, there are two distinct solutions. If it's equal to 0, then that means that there's only one solution. And if it's less than 0, that means that there is no solution. So in this case, b equals 2, a equals 1, that invisible 1 that's out front, and c equals 3. So b squared minus 4ac is negative 2 squared minus 4 times a is 1 times c is 3. And that equals 4 minus 12, which is less than 0. So once again, there is no solution. And we could go ahead and sketch the graph of these. And that's a real easy check when there is no solution, because the graphs don't touch. The curves don't touch for both equations. So the first equation, if we rewrite that as y equals x squared, well, we know what y equals x squared looks like. Centered at the origin, or vertex at the origin, and opening up. And then y equals 2x minus 3, that has a y-intercept of negative 3. And an x-intercept of 3 halves. So 1 and a half. And I made my parabola a little wide here. I need to change my scale. Obviously, you would be using a more proper scale than what I am here. But when we graph the line in the parabola, we'd see that they don't intersect at any point. And that's because of the slope of the line being less steep than what the slope of the curve is anywhere, the curve for the parabola anywhere that it might be even close.